Hey guys, this is Miss Dupe, and today we are going to talk about infinite and no solutions when we are solving equations. So infinite and no solutions are two different type of solutions that you can get when solving in equations. First, we're going to talk about what it looks like when you have one solution. So every equation that we have solved so far, with the exception of the last problem in the video on Friday, if you watched the video, have been one solution. So one solution answers, I'm terrible at spelling, looks like x equals 1, or a equals -3, or m equals 2. It's just normal answers like we've been getting. So every answer that we've been getting so far where we have a variable equals a number is just one solution. That means you just get one answer and one number for that answer. So infinite and no solutions are different. Infinite solutions is when you could put any number in for x or whatever variable you're dealing with, and you will get an answer every time. Any number satisfies x. So your answers will have basically the same thing equals the same thing. So for example, you could get an answer like on Friday's video where we get 0 equals 0. Or we could get x equals x, or we could get 2 equals 2. Everything equals each other when you get the answer. So one solution is when you have a variable equals a number. Infinite solution is when you have the same thing equals the same thing. And then we have no solutions. No solutions are when our answers don't make sense. So this is when we have a number that equals a number that's not true. For example, 10 equals 1. That is not true. 10 does not equal 1. You could get -2 equals +2. -2 does not equal +2, so that is not true. That's not a correct solution, so there's no solution. Or you could get 0 equals 5. 0 does not equal 5. That is not true. So now we're just going to go through 4 different examples of solving equations and then ending up with an answer type like infinite or no solutions. Our first example is written down here, 4x plus 2 equals 2x plus 1. So like we have been doing for the last few days, we're going to start simplifying this equation by distributing 2 to both parts in the parentheses. We are going to write down 4x plus 2 equals, and then multiply in that number in front of the parentheses. So 2 times 2x gets us a 4x, and 2 times 1 gets us a +2. So now we're going to go ahead and start solving like normal. Remember, we want to move our variables to the left and our constants to the right. So we're going to move our 4x over to the other side by doing subtraction. Now we get 4x minus 4x, which ends up being 0. That's totally fine. Now we're going to move our constants over to the right, so we are going to subtract 2 from both sides. This is the 2 we wanted to move, so we're going to cross it out, and now we have +2 minus 2, which is also 0. Now we have 0 equals 0. Well, if we look at the top here at our infinite and no solutions, our answer type would match what infinite solutions would be because we have the same thing equals the same thing. So for our final answer, we're just going to write infinite solution. Here we have our second example that we're going to go through. So as you can see, we need to do some simplifying at the beginning by using our distributive property. So we are going to distribute on both the left and also the right side of the equation. So we need to do 3 times 6, which is 18, and 3 times negative 4x, which is negative 12x. Bring down our equal sign, and then negative 2 times 6x, which is negative 12x, and negative 2 times negative 9, which is a positive 18. Now we are going to start moving our variables to the left and our constants to the right. So we are going to move this 12x on the right over to the left by adding, because it's negative. And we get a negative 12x plus 12x, which negative 12 plus 12 gets us a 0. Now we're going to move our constants to the right-hand side. So we are going to subtract 18 from the left to move it over to the right. And on the other side of the equal sign, we have 18 minus 18, which actually ends up getting us a 0 as well. So once again, if you look at infinite and no solutions, we do end up getting 0 equals 0 again, which is the same thing equals the same thing. So this is going to be another infinite solutions example. Here we have our third example, and luckily we don't have any distribution in this problem, so we can go ahead and start solving by moving our variables to the left and constants to the right. So we want to move this 3x from the right to the left by subtracting, since it's positive. We're going to cross those out since that's the one we want to eliminate. And then we have 3x minus 3x, which ends up going away as well. Now we are going to move our constants to the right. So we are going to move 4 by subtracting, cross out the 4's. We'll bring down our equal sign and have 3 minus 4, which is negative 1. Now we get to the end here where we have 0 equals 1. Well, 0 equals 1 is not true at all. So that means that this is a no solutions. For our final example for our infinite and no solutions notes, we are going to go ahead and simplify using distribution again. We just really need that practice anyways. So we're going to bring down our 4x minus 6 and our equal sign, and then multiply 2 times 2x, which is 4x. And then 2 times negative 1, which is negative 2. And then we are going to start solving by moving our variables to the left and our constants to the right. So 4x from the right-hand side is what we want to move by subtracting, since it is positive. And 4x minus 4x does get us 0. At the same time, we are going to move our negative 6 over to the right-hand side by adding 6 to both sides. We bring down our equal sign, and negative 2 plus 6 equals positive 4. So now we have 0 equals 4. 0 does not equal 4, so that's not true. Therefore, this doesn't make sense, and we get no solutions for our answer. So that is it for our infinite and no solutions notes. I hope that this is some good extra practice for solving equations, and that you understand what getting one solution, infinite solutions, and no solutions means.